Normally inside the parentheses, x minus 2, we shift to the right 2 units. We have no units. Our units are angles. So we call it a phase shift. So we shift over by angles. And it still works the same way. We go the opposite way, but we have a little formula that says C over B. And you have to follow that. And that's going to tell you where to start. The same thing when you did this, and you started your and you had your parabola here at the vertex. If you did this, you moved 2 to the right. It's the same movement, same shift, but the problem is we don't have units, we have angles. So they call it a phase, like the phase of the moon. The moon has different phases. It goes through different, it's a circle, but it goes through different angles that it's open with. This is the work I should see on your papers. So vertical shrink, I hardly saw anybody that put their transformations. A vertical shrink, give me the range, it asks for the range. Find B, find the period. Horizontal stretch by a factor of 2. Where did this 2 come from, horizontal stretch? Where did that come from? The half. Where's the half? Good. It's the x over 2. Good. There's the 1/2. If I stretch something by a half, could I stretch it by a half? I got to stretch it by a number bigger than 1. So these work the opposite of what our other things do. It's a stretch by a factor of 2. It has a phase shift. So it's not starting at the 0, 0. It's starting at the pi over 2. This is my first piece of information that I need to know to graph this. What's my second piece of information? What would be your second piece of information? Okay, I need to know an amplitude. That's another piece I need to know. What else? I need to get this on a sketch.
Sine curve. Original theory.
The original cosine curve. Good. So I know my original cosine curve. I'm going to use my amplitude. I'm going to change my amplitude. Were there any vertical shifts at all? So life is easy. There's my pattern. There's my pattern. Now, what else do I need to know to put this on a graph? Which a lot of you I didn't see. Can't wing me a curve. What do I need? Where it starts, where it stops, and all those little guys in between, what are those called? I need increments. And how do I increment this curve? Where do I put my little dots?
Oh, I have a question.
Go ahead.
Wouldn't it be a vertical stretch by 2 to 3 units because that's greater than 1?
That's 2 over 3. It's less than 1. 2/3.
Oh, I think
3 over 2 would be a vertical stretch.
Yeah,
And you could, well, I'm glad you brought it up because 3 over 2 is a fraction, but it is greater than 1. So that would be a stretch.
Yeah.
And that's usually something kids see a fraction and they automatically say shrink. So I need to know, what are my increments? How do I increment this thing? This is the hardest thing for me to do. So where do I get my increments from? Where do my increments come from, Mitch?
Take your period and divide it by 4.
Perfect. You take your period. Your period is 4 pi. So I know how long it's going to take me to complete 1 cycle. I take my period, I divide it by 4 because there are 4 quadrants in your unit circle, in your any circle. You go through 4 quadrants. That will tell me every pi I need to put a tick mark. Now my problem is, it would be nice if this was 0 and I could do every pi. I'd have no problem doing this, but I didn't start here. I started here at pi over 2. So make life easy. There's a pi, that way. There's a pi. If you want to put a little x here, just so that you know where to graph, just put a little x so that you can figure out where's your next mark going. That seems to be one of the hardest things that everybody has a tough time with. Where do I put my next one? I know where to start this guy. Where do I go next? If I have to go pi over here, and these were pi, I separated them. So the next mark here, the next mark here. To put your, if you have to, mark it off. Put a little X on it. I will know what your X means. And then I asked you to find your maximums and minimums and your zeros. There are a lot of these things because you did 2 cycles worth. So here's a max, here's a max, here's a max. Here's a min, and here's your zeros. All you have to do is label me those points. Just label them. A point is X and Y. An angle is your X-axis. The 2/3 is your Y-axis. It's either going to be a 2/3, a negative 2/3, or a 0, and I think I forgot your negatives over here. Negative 2/3, and your zero's 0. Can you do this? Can you find where the cycle ends, where it begins and where it ends? So if I take this piece and I set this equal to 0, and then I set this equal to 2 pi, I don't know why that writing came out so weird, probably most of it's my handwriting, but if you set it equal to 0 and set it equal to 2 pi, it'll tell you where your cycle is. That's one cycle. I wanted 2. So add another 2 pi to both of them. See where you're to the last one. Just add 2 pi to it. See where, 4 pi is your period. Add 4 pi to it. See where you're going. See where it's going to end. Or think it out. If we said the period, here, if your period is 4 pi, you're going to normally take 8 pi to do this, right? To do 2 cycles. Normally you would take 8 pi. 0 to 4 pi, 4 pi to 8 pi. If you shift it to the right 90, just take 4 pi and add 90 to it. I realize it's a fraction, just make a common denominator. And then you can figure out, well, there's my 4 pi, my pi over 2, I get 1 cycle. If you want to just throw it in, add 8 pi. Add 8 pi and get where you're going to end up. But you need to be able to do this. Questions? I hope you wrote this down, because you're going to get this on your test.
Can you just scroll down again?
You don't do it all.
I don't do it, oh well. We don't do it and say we did. How about a tangent using y and x? So the tangent of an angle is y over x. So the tangent at 0, let's plot your tangent at 0. Y over x, 0. Your tangent at 90, y over x. No tangent, y. Undefined. So we have an asymptote here. I cannot use 90. Can't happen. Tangent at 180. Yeah, still be 0. Tangent at 270. 3 pi over 2. Nope, can't divide by 0. I have another asymptote that says don't touch those. And I'm back to 0, back to 0. So a little hard to graph my tangent curve here. I really don't have a heck of a lot of points here. If I do the negative 90, this is going to be my asymptote. This is going to be my asymptote. These are going to be my zeros. So I need a couple of more points in here to graph. So the tangent of 45 is what? 1. Because the legs are the same, right? I'm going to put a 45-degree triangle in here if you can see this. And they're whatever, 1 over radical 2, 1 over radical 2. So anything over itself is 1. So the tangent of 45 is 1. We're just going to work with this right now. So if this is 45, these are 45s in between, agree? We're sketching. We need some kind of tick marks here. We can't wing these things. So the tangent at 45 is 1. What is the tangent at negative 45? Negative 1. What is the tangent at this quadrant, in quadrant 2? Negative 1, because the x is negative, the y is positive. So at 3 pi over 4, right in between here, I'm at a negative. What is the tangent in quadrant 3? A positive 1. I'm only doing 45-degree angles. Okay, quadrant 4, what is the tangent? Negative. So, tangent doesn't have a curve, obviously, because it has asymptotes. So, tangent goes like this. Kind of makes this squiggle in between. And can you see we're all we need is the 45-degree angle to help us. It'll keep on going like this. And it'll do the same over here. And it'll keep on doing this. See the pattern? Tangent is not a continuous curve because we have asymptotes. There are a couple of angles that don't let us take a tangent because we can't divide by 0. It's undefined. So there have breaks in this. That's why we do the tangent completely separate because it does not behave like a cosine or sine curve. Now, just looking at this, can you see a pattern? What do you see? As simple as what you see.
Every half full cycle.
Okay, so what do you consider a full cycle? Tell me from where to where.
From the 0 to 2 pi.
So 0 to 2 pi. Do you see like a cycle and you see a pattern in here? Can you narrow down your pattern?
There's no point and a point and no point.
No point and a point, right? All the quadrants are either undefined or they're zeros. That's a good one. All the quadrants are either undefined or they're zeros. Just looking at this, the squiggle line thing. Can you tell me anything about that you notice, Alexi?
It like moves over.
How many?
An increment of pi.
Okay, on an increment of pi. So from here to here, you're saying this is an increment of pi, and then I'm an increment of pi over here. So what's my period? Pi. So the period for this guy is pi. What's my period for sine curve? 2 pi. My period for tangent is different. Every pi, I make another squiggle thing. I have the point, the resting point at the 0. I have a point below, a point above. And you guys did a great job noticing this. So if I had to describe my domain, how could you describe your domain? They're not used, they're just like continue, they go down. Okay, let's do this one first. What's my range? So they go down and continue. These guys go down forever. They go up here forever. So just describe me what you see. Describe. I can do almost every angle. So let's just say almost all real numbers except what? Increments of 90. Okay? Except increments of 90. Good so far?
You write real /
Okay, don't write it. You just work with me for a minute. So increments of 90. So if I started here at the 0 and I go here to 90, I can't use this. If I go another degree, another 90, I'm at pi. Pi is an increment of 90. Can I use pi? So we're on the right track. Let's narrow this down just a little bit more. Which 90s can I not use?
Every other.
Every other. So every other starting from where? We're so close.
Pi over 2.
Every other from pi over 2. So look at this. This is 1 pi over 2. This is 3 pi over 2. Over here, what is my next increment of my asymptote going to be? 5 pi over 2. So what do you notice? Every odd, every other, every odd increment of 90. Okay, so we narrowed this down a little bit. So we can use increments of 90 because we can use 0, we can use pi, we can use 2 pi. We can't use pi over 2, 3 pi over 2, 5 pi over 2, 7 pi over 2, 9 pi over 2. So we have to narrow this down a little bit. So we're going to say this. The domain is real numbers except when x is equal to n pi over 2. So far so good? Where n is an odd integer. Write it down and then we'll see if that's what we came up with. Trust me, it works. We'll go through this. So I can use all my angles basically. This little slash line means except. except, I have exceptions. Pretty much I can use everything except take out where pi over 2, every increment of pi over 2, I can still use some. I can't use the odd ones. So I have to have a way of making this odd. So I say n pi over 2, where n is an odd integer. So 1 pi over 2, 3 pi over 2, 5 pi over 2, 7 pi over 2, not negative 3 pi over 2, negative 5 pi over 2. Make sense? So here's my domain. And therefore, where are my asymptotes? If I ask you to describe your asymptotes based off of this, where are your asymptotes at? Use your exceptions in your domain. Your exceptions are what? Your exceptions are your asymptotes. So what are my asymptotes? X equals n pi over 2, where n is an odd integer. These are my asymptotes. Didn't you say don't use those? Except, that little slash line means except. That little slash line means except.
What should we be writing past the slash line? You wrote a lot of stuff.
And that's what you have to write. You have to write that because you're qualifying this. It's not every pi over 2. I can use pi, which is a factor of pi over 2. I can use 0. I can use 2 pi. I can't use 1 pi, 3 pi over 2, 5 pi over 2, 7 pi over 2. I can't use those odd ones. So I have to qualify this and say it can't be odd.
No, I was wondering, like, because you wrote it like kind of twice, like 2 different domains.
Yeah, well, we were coming up with this one together. I said don't write this. We were just coming up with this. This is the real one. We were coming up with this. So I wanted to brainstorm, and that's when I said to Miguel, don't write this, just like work with me here. So I'm sorry, that probably confused you. So isn't this really just, we started out with they're real, except we couldn't use 90s. So when we took a look at it, there's only certain 90s we couldn't use. So I wanted you guys to come up with this. Miguel.
You write real numbers or just real?
You say real. Real numbers, real and angles, whatever you want to say. Real is fine. You could write negative infinity to positive infinity, but it kind of looks strange. Did you guys ever write your set notation like this with the except sign in it? Okay. Did you ever write your things where you did this? X such that, X is equal to, did you set notation?
We did this year, though.
We did this year. We did this. And didn't we do the except in there?
Yeah.
We did an except in there, right?
Except.
Okay.
Yeah.
All right. So now we're going to go
Thing is,
to
why are you doing this?
cotangent. We're going to go to cotangent. Cotangent is what? The reciprocal of tangent, 1 over tangent. So in terms of x and y, it's x over y. It's the reciprocal. Okay, so at 0, what is your cotangent? It's undefined. I can't divide by 0. Asymptote. So looking at that, without doing the next one, where do you think my next undefined is? At pi, because why? Because it's every other, because that's where, if this is where my 0 is here, isn't my 0 the same place here? Aren't I going to have trouble dividing by 0? You don't have this. It should be the last one. You do. Okay. So isn't, if this is the 0, isn't this the 0 too? That's going to cause me trouble. So at pi, again at 2 pi, right, because I'm back to 0. Okay, so we're going to use our favorite angle again. We're going to do your 90s, and then we're going to use our 45s. So at 90, what is my cotangent? At 90? 0, because it's x over y, so 90 is a 0. 270 is a 0. We got the same situation, but just opposite bars, if you will. So we're going to use our 45 again. So our 45, the tangent and the cotangent are the same, right? Because it's 1. So 1 over 1 is still 1. So in quadrant 1, here's my quadrant 1. This is my 45s now. Increment by 45s. We just need something to give us a dot on there. God bless you. So 45 is a 1. In quadrant 2, it is a -1. So look where it's going. Kind of like the opposite way. So again, quadrant, your quadrant 3 down here, it's negative. It's a negative divided by a negative, which is what? I'm only at the 45s. In quadrant 4, it is a negative divided by a positive. I'm a negative. See the pattern? So I can just go like this. Put these here. What's the period for cotangent? How long does it take me to complete one of those squiggle lines? Pi, this one's even nicer, isn't it? From 0 to pi, I get a section, right? So my period is pi. It just takes me 180 degrees to do this. So what's my range? Let's do the easy one. Okay, now let's see if we can do our domain. We're going to say real numbers except when x is equal to what?
When I completed the pi,
Oh, so you can't use 0. Let's see the ones we can't use. We can't use pi. What's the next one? 2 pi. How about we can't use -1 pi. We can't use -2 pi. Every pi. And pi. Okay. N is, can I use 1? 1 pi? So I can't use 1 pi either, right? So I can't use that one. I can't use 2 pi. I can't use 0. Where n is any integer. Any integer. We're just defining these. That's all we're doing. Okay, so where's the asymptotes at? N pi. X is n pi, where n is any integer. Now the reason we have to qualify n is because on the other one we could only use it when it was odd. This one we can use any integer. We can't say any number because any number means like 1.2, 3, 3/4. We can only use integers on this. Is 0 an integer? Yes. So it gets through with a 0 as well. We don't do a whole lot with these guys. Our basic focus is usually the sine and the cosine curve, but we do throw some of these at you because of their domain restrictions. Questions so far? All right. I know I'm not going to have time to do one of these, but I do want to do one of the homeworks with you so that you can do some of these. I'm only going to ask you to do the tangents and the cotangents on the homework. So if you kindly look at number 2, I'll walk through homework with you. Okay, so before we did this, what's the difference?
so we're,
It has a B, which is what? 1/2. So the frequency is 1/2. Okay. Which means what to me? The period of tangent is what? Pi. So I'm going to do half the curve in pi. So what's my period going to be? 2 pi. Okay, so every 2 pi, I should get a curve, right? So if my period is pi, I'm doing half of this. So divide this by 1/2, technically. So keep change flip. My new period for this guy should be 2 pi. It's going to go out to here. All right, let's just go to like 1 and -1. Did I change the amplitude at all for this? It's kind of hard to change the amplitude for tangent because tangent is all real numbers in the range, but it will change the sharpness a little bit. But I'm really not too worried about that.
For period, isn't it 2 pi over 1/2? Or like not?
No, because your period for tangent is
Oh,
pi. It's different because it's not a curve. Okay, so now, here's the easiest way to do this. Take this guy and set this to where your exceptions are. Your exceptions are n pi over 2, where n is any odd integer. This was my normal range, wasn't it? I need to find out where my exceptions are, because those are my asymptotes. So set it equal to what tangent normally is. Now, because these are the same, the numerators are automatically the same. However, I need this qualifier. Give me 1 second. So at every n pi odd integer, 1 and -1, I'm going to put asymptotes. And my tangent curve is going to just go right through here. Where would be my next asymptote? At the odd, at the 3. And here, we'll go through again. Try the tangent and the cotangent. Only the ones that say tangent and cotangent.